Alright, so our next topic for today's lesson is cubic interpolation method. Okay, right. In our last class we have done with quadratic, right? Okay, so right now we have done with direct search method. Okay, which is Fibonacci and also golden search. Okay, so in this both direct search method here use only reducing of interval, right? But for golden search, we reduce the interval at the value of top. Okay, this one depends on the value of points at each iteration, right? And then we have interpolation. Okay, in interpolation method, we have quadratic. Okay, and we have now cubic. Okay, so in quadratic, what you have done in quadratic is by discarding the value of x4, remember? Okay, we have x1, x2, x3, and x4. So we discard what? Discard the highest. Okay, so what are the purpose of doing this? Because we want to reach the optimal point, the solution point. We reducing the interval. Here also we reducing the interval by discarding the point, but the methods is quite different for each of the methods. But our purpose is to find what? Is to find either maximum or minimum point. Okay, maximum or minimum point. Let's say we have here. This one also maximum or. Okay, so we want to identify the solution point. Okay, why there are many methods in order to find optimal solution? Because what we need to consider is the number of iteration, the times used in calculating up to the solution point and so on. So that's why there are many methods that we can use in order to find the extremizer. Either it is maximum or minimum. Okay, clear everyone? So these are the methods. So what we have done previously is direct search method and also interpolation. So now we proceed with cubic interpolation method. Okay, so still it is interpolation method, but with this cubic, what is the difference between the quadratic interpolation? Okay, I hope you have read this. Okay, so the dividend is not Davidson, dividend of the present section is more accurate and approximate because we use cubic polynomial. Okay, it used the value of the function and its gradient at 2 points. Okay, we use the gradient at 2 points in order to fit the cubic so that we can reduce the interval in order to reach our solution point. Okay, remember our purpose is to reach the solution point. So it is widely used in the context of linear searches and we should treat it as a point of view. So it is by using linear searches. Okay, we are going to use a straight line. Discussed here are the number of interpolation methods. Okay, even though it is accurate, it is more accurate in this interpolation method. It quite an exhaustive list. Okay, the calculation is quite long, but the methods shown tend to be those in common use in computer graphics. Okay, even though the manual calculation is quite exhaustive, but it is quite accurate in terms of computer graphics. Okay, the main attributes is that they are easy to compute and are stable. Okay, so easy to compute and stable. So interpolation are used here is different with smoothing. The techniques discussed here have the characteristic that the estimated curve passes through all the given points. Okay, so we passes through all the given points. So the idea here is that the points are in some sense correct and lie on underlying but unknown curve. Okay, the problem is to be able to estimate. We want to estimate of the curve at any position between the known points. Okay, so cubic is the simplest method that offers true continuity between the segments. As such, it requires more than just two endpoints of the segment, but also the two endpoints of either side of them. This does raise issues for how to interpolate between the first and last segment. So we use interpolation method. Okay, so what we can summarize from here, we use the cubic interpolation method to fit into cubic polynomial. Okay, we find values and then gradient on linear searches. Okay, where it passes through all the given points, and we can use to estimate the values of the curve at any position between the known points. Okay, let's take a look at the graph. So it can be illustrated as, okay, let's say you have your x0. This is your set length. Let's say this is your curve. Okay, then this is your gradient at g0. So this is the line. Okay, and then this is your alpha. Okay, and this is the function. And here is the point of x0 plus ht, where d here is the direction. H here is your step line. Okay, so let's take a look. So now this cubic, okay, this cubic use a common solution, which is to dream up two extra points at the start and end of the sequence. So two extra points here and here at the start and end of the sequence. The new endpoints are created so that they have a slope, equal to the slope of the start or end segment. Okay, it is more accurate compared to quadratic, because in quadratic, what we have done in quadratic, okay, we just choose any 4 points and then discard the highest point, and then again choose 3 here, and then we can have any 4 point, discard the highest point, and then choose again and again and again. Okay, but for this cubic, we consider, why it is more accurate, because we consider the the slope. Okay, slope at the start or end of the segment. Okay, now we approximate the function with a cubic polynomial and use the value of the function and its gradient at two different points. Okay, here and here. Okay, now consider the problem. Okay, consider the problem of minimized function fx at points on the line x0 plus ht. Okay, this is x0 plus ht. And then, which is to minimize the function. So this is the function that we want to minimize, where x0 is your current point here. Okay, and d is the given direction towards here. Okay, now let f0 and f alpha are known, where alpha is a value of h. What is h? H is a step length. Then we can find the gradient by differentiate the function. Okay, we can find the gradient g0 and g alpha, and gx here is the gradient of f. Okay, and g0 should less than 0 to reach the minimum point. Okay, so now how can we operate this method? Okay, we have divided this method into 3 different levels, right? So first, we need to find magnitude of Hm, okay, to approximate the minimum value of H. Okay, we need to identify the step length and then obtain the lower limit and upper limit of Hm. And the third level is the cubic interpolation, which is applied to obtain a better limits of Hm. Okay, for the first level, where we want to find the magnitude of Hm, okay, usually the parameter alpha is taken, right? Usually the parameter alpha here is taken as initial approximate of Hm. So at first iteration, your Hm is given by alpha. Okay, there is a problem to find a value of alpha which can satisfy all problems. So we have come up with this formula where we choose the alpha which is equals to the minimum value between these two. Okay, either it is eta here or minus 2 f naught minus fe over g naught, where this value is usually either 1 or 2, and we often choose 1, okay, as your eta value there. Okay, and fe is an approximate value. It is usually less than the real minimum value of fx naught plus hd. Okay, and then second level, okay, first level, we identify our alpha and step length. In second level, since G naught less than 0, if G alpha greater than 0, then the minimum lies between H equals to 0 to alpha. Okay, and then here can be illustrated as this is your function. So this is when f naught greater than f alpha. This is f naught less than f alpha. So as you can see, the minimum lies when h from 0 to h to alpha and f lambda greater than 0. This one. Okay. So if these 3 conditions are fulfilled, okay, double the value of alpha repeatedly until the minimum value is bracket. Then we proceed with the third level. Okay, for the third level, the function fx naught plus hd is approximated by a cubic function. So this is your cubic function. And we obtain the value of a, b, c, and d by solving the function here. Okay. By solving the function here simultaneously, where we differentiate here where h equals to 0. All right. Then we can find what are the values of base a, b, c, and d, and z. And we can obtain z. So for each iteration, you need to calculate each of the values here. After this, we can take a look at the example. And then differentiate the cubic function with respect to h. We obtain the turning points of the fitted cubic, which are the solution of psi prime equals to 0. Okay, so this is the equation forming from here. Okay, and then so if Hm is the minimum location of the cubic, then Hm over alpha, which is given by this, or Hm equals to this times with alpha, where W equals to this, then the second derivative of psi H is this. Then for minimum, psi double prime H greater than 0 will give you this. Okay. All right. So we are going to stop when the bracket interpolation is less than the number of stopping criteria, our epsilon. Okay, I know it's quite confusing, okay, with all of this theory, but let's see the example after this. Okay, so what are our algorithm? Okay, first, right, look at here. First, you need to evaluate F naught and G naught. Okay, evaluate F naught and G naught. Then you need to check where G naught less than 0 or not. Okay, so when G naught less than 0, then proceed. If not, okay, if not, what you need to do is D, the direction equals to negative D. Okay, just modify that. Okay, and then once G naught less than 0, choose the values of eta and Fe and determine the value of alpha. Okay, evaluate F alpha and G alpha, right? And if G alpha greater than 0, okay, this one, evaluate alpha, F alpha and G alpha. And if G alpha greater than 0 or F alpha greater than F naught, continue to step 5. If not, go to step 4. Okay. Here, if it is greater than 0, continue to step 5. Right? Where we have to find the new interval of interpolation method. Where we want to identify HM. We need to proceed with the calculation, okay, until you get the smaller interval of interpolation interval here, okay, for which 0HM if GHM greater than 0 or HM alpha if GH alpha less or equals to 0 by using the value from ZWHM previously. How can we obtain ZW and HM is discussed here. Okay, this one. You can take a look at the note. All right. And then we proceed with B. What is B? Okay, now you have to calculate your FHM and GHM. All right. And then once the magnitude of GHM less than epsilon, then we stop the process. Minimization process complete. If not, so we should update our step length and also the iteration point. Okay, so that is the process, which is quite long. And I know that this is quite confusing, right? Understand or not? I'm not sure you understand or not. Okay, guys? Yes, we have to do example. Otherwise, you won't understand where are these steps are applied to. Okay, let's choose one tutorial question. So let's discuss these. By using the flow chart here. Okay, we want to minimize along the line through -1, 0 in the direction of epsilon and d are given there. Okay. So what are those values? Okay, so this is your function. This is your function. Okay, along the line. So this is your what? Your initial point, -1, 0. In the direction epsilon, this is your epsilon stopping criteria direction 5, 1, FE equals to 0. So basically, if you have FE here, then you know that this is cubic interpolation method. So what is FE? Okay. Again, what is our FE? FE is used to find the value of alpha. Okay, remember you need to find the value of alpha in our first step to determine the value of alpha. Okay, so now let's start. So in our first iteration, okay, you use x0, f0, g0. So let's start with iteration 0. Okay, your x0 is given by -1, 0. This is your x0. Okay, and then you have your function. So given x0 minus 1, 0. So what is your f0? Calculate your f0. What is your f0? You don't have your calculator with you? All right, so 104. Okay, evaluate f0 and g0. Check whether g0 less than 0. Choose the value of beta and e and determine the value of alpha. So now, what is g0? Okay, what is g0? Let's take a look. G0 is given by, okay, gx transpose times d, where gx is the gradient of fx. Okay, so now, in order to find g0, okay, we need to find derivative of f at initial point, where we have here, what? We have here two variables, so you need to differentiate partially with respect to x1 and x2 each. Okay, so here we have what? 2, 2, so minus 400 x1, x1 minus x2, x2 minus x1 squared, okay, minus 2, 1 minus x1. Okay, and then another one, 200 x2 minus x1 squared. Okay, this one, the first one, where we differentiate function with respect to x1. Okay, the second one, we differentiate the function with respect to x2. All right, so this is your derivative of f. Now, derivative of f at x0, so you just substitute x0 with what? Minus 1, minus 1. I skip the calculation here, which is, okay, this one, in this step, you substitute x1 with minus 1, x2 with 0, then you get minus 404 and minus 200. Okay, so now this is your delta f0. Now you have your f0, evaluate f0. Now you want to evaluate g0. So g0 is what? G0 is given by delta f X transpose times with D. Okay, where G naught, so delta Fx naught. Then this one we transpose becomes minus 404 minus 200 times with D. D is direction of 5, 1. So you will get your G naught negative 2, 2, 2, 0. Okay, check whether this is less than 0 or not. So this one, G naught less than 0. So what if G naught less than 0? Now G naught less than 0, then we can find alpha here. Okay, clear? Understand or not? So now G naught less than 0, we can find alpha. So how can we find alpha? So there is the formula of finding alpha there. Alpha is the minimum eta minus 2 F naught minus Fe over G naught. So in order to find alpha, alpha equals to minimum eta minus 2 F naught minus Fe over G naught, which give you, remember what is our eta? What is our option for eta? We always choose the value of what? This one? Eta is a constant. Okay, it can be either 1 or 2, and usually we always choose 1. Okay, so 1 minus 2, F naught is 104, Fe is given, okay, and G naught is minus 2220. Okay, now it is either 1 or 0.0937. So it is either these values where we need to choose the minimum one, which is alpha equals to 0.0937. Okay, clear now? First, we identify your X naught, F naught, and then we have to find G naught. In order to find G naught, you need to differentiate F so that we can use its gradient and just substitute X naught to find delta F naught, where delta F naught here is used to find G naught, which is delta F naught transpose times D. Then you need to check whether G naught is less or equals is less or greater than 0. So if it is less than 0, then we can find the value of alpha. If not, then what? If G naught greater than 0, then we change the direction of G. Okay, D equals to negative D. So now we have alpha. Right? We have our X naught, we have our F naught, we have our G naught. Now we have our alpha. And then what? Step 2, evaluate F alpha and G alpha. All right, clear or not, everyone? So now, what is F alpha and G alpha? Okay, let's take a look at the note. So this is your alpha. Okay, this is your F alpha. Okay, F alpha is given by F as X naught plus HMD. Because for the first level, usually the parameter alpha is taken as initial approximation of HM because there is no start length yet. Right? There is problem to find the value of alpha. So this one in the first level, we have to find alpha and then we substitute to Fx naught plus HMD because this is only our first level. Okay, now in order to find F alpha, we have to find X naught plus HD, which is H here is alpha. Okay. Where x0 is what? X0 is minus 1, 0 plus with alpha times with D. And you will have minus 0.5315, 0.0937. So this is your f x0 plus alpha D, which is given by f alpha. So substitute this to f. Okay, substitute this to f x0 plus alpha D. Just substitute to f. Okay. And you will have your f alpha equals to 5.9097. Okay, I use my value first. If there is mistake after this, you can check. This is just for explanation. Okay, I hope there is no mistake. Okay, so now we have done with f alpha. Then, what is g alpha? Okay, what is g alpha? Again, G alpha is given by G x0 plus alpha D transpose D. So same process. Okay. Tadi kita buat G0. Now G alpha. Just use the same process. So if your F alpha is given by this, then G alpha is given by what? G x0 plus alpha D transpose times with D. Okay. So you have to have what? You have to have delta f x0 plus alpha D first. How can you obtain this delta f x0 plus alpha D? You have your value of x0 plus alpha D here. Okay, this one. Then in order to get the derivative of f x0 alpha D, just use this negative delta fx here. Okay, this is your delta f. Just substitute your x here with x0 plus alpha D here with alpha here. Okay, clear now? Any question? Okay, just substitute that. You can get this one is minus 43.2002. This is the transpose version already. 200. Okay, transpose times with direction. Now it is equals to minus 253.7595. This is your G alpha. This is your F alpha. So now you have to check, right? If G alpha greater than 0 or F alpha greater than F0, continue to step 1. So now you have to check. Now, what are the conditions? G alpha less than 0. Okay, now F alpha and G alpha, F alpha less than F0, right? F alpha greater, G alpha greater. So if it is greater, then we can proceed with step 5. If not, go to step 4. Okay, here. If it is greater, then proceed. If it is less than, replace alpha by 2 alpha. Okay, in step 4, substitute alpha with 2 alpha, evaluate new F alpha and G alpha, and then go back. Understand or not? So now you have your alpha, right? Alpha equals to minus 0.5315, 0.0937. So since we have less than 0, okay, sorry. What is our alpha? Alpha is here. Sorry, this is not alpha. This is alpha. Okay. Now, since G alpha less than 0 and F alpha less than F naught, we need to replace alpha with 2 alpha. So now your X naught plus with 2 alpha D. Okay, so that your F alpha is given by Fx naught plus 2 alpha D, and your G alpha is given by G x naught plus 2 alpha D transpose times D. Okay, try to calculate this. What is your x naught plus 2 alpha D there? Anyone? Okay, minus 0. Right, so as x naught plus 2 alpha D, you have minus 0.061, 0.187. Okay, so now just substitute to your F here. F alpha, okay, and then find G to alpha. F to alpha, just substitute the value of these to F. Okay, you will get 4.4947. And then substitute to the derivative of F so that you can get G transpose times with D. And you will have 49.1687. Okay, this one, how you obtain, just substitute to the derivative of fx naught plus 2 alpha D, and then you transpose, multiply with D. Okay, so now you check again. Now, G alpha, which is G to alpha, your new G alpha, which is G to alpha, is greater than 0. And, ataupun or F2 alpha, which is 4.49, is greater than F naught. Where is your F naught? F naught is 104. Is it? No, right? Not greater, but we just choose only one because we have all there. Okay, at least one of these two match, then we can pass it. Okay, so now G2 alpha is greater than 0. So what's next? If it is greater than 0, continue to step 5. So step 5, interpolation interval. So now, hence, your interpolation interval of 0 alpha equals to what? For HM now, equals to 0. What is your alpha? 2 alpha. 2 times alpha, which is equals to, okay? Is that clear? Interpolation interval is 0 alpha, but from this case, the alpha is cannot be used because we met the condition of G alpha less than 0. So we double the value of 2 alpha. So now this alpha is actually 2 alpha. Okay, 0.187. All right, clear up to this point. So now what's next? Once we have our HM, okay, look at the once we have our HM, step number 6, we need to calculate our GWH and X1. Okay, where now we get our HM, proceed with step number 6, which is find Z equals to 3F0 minus F alpha over alpha plus G0 plus G alpha. W equals to set of Z square minus G0 G alpha. And HM, your new HM, is given by G0 plus Z plus W times G0 plus G alpha plus 2Z times with alpha, and X1 equals to X0 plus HMD. Okay, so substitute everything. So your Z, okay, your Z here we use, since here we use 2 alpha, then this is 2 alpha. This is 2 alpha. This is 2 alpha. Just substitute 3 times F0 times F2 alpha over 2 alpha. Okay, because we use 2 alpha here. All right, this one also 2 alpha. Okay, just substitute. Now what is your Z? Okay, your Z equals to 3 times F0 is 104. F2 alpha 4.4. 947 divide by 2 alpha 0.187 minus plus G0 is minus 220 plus G2 alpha 49.1687 equals to negative 577.8969. Right, and then W set of Z square, you have your Z, okay? Z is minus 577.8969 square minus with G0 negative 2220 times with G2 alpha 49.1687. So square root them, which give you 665.67. Okay. And then H1. Okay, we have our H before this, which comes from alpha. Now your H1 equals to G naught negative 2220 plus with Z plus with W divide by G naught plus with G to alpha 49 plus with 2Z. 2Z. Z is minus 577.8969 times with 2 alpha. Okay, which gives you 0.1201. Okay, so this is your H1. Okay. All right. So now this is your new interval, new start line. Okay. Previously we have our H1 is 0.1201. Okay. So previously we have alpha, right? Alpha here, 0.0937. Now this alpha in the next iteration is your H here. X naught plus H, right? Remember, in our first level, okay, we use alpha, but it is actually X naught plus HMD. So now you have your HM, which is your new H1. Okay, then in the next iteration, your X1 equals to X naught plus H1D. So this is your new iterates point, and your current X naught still your X naught, and proceed with the same process again until when? Until the interpolation interval is less than epsilon. This one. Okay. We have identified HM, right? Then go back to step 5 to repeat the interpolation in a smaller interval if, okay, this one, if GHM greater than 0, right? But if not, proceed and stop when the interpolation interval reduced to a certain value, which is epsilon. Okay, so let's proceed. Okay, any question up to this point? It is such a long calculation. You are going to have 8 iterations for this example. Any question? Now we have up until x1 here. No question. Okay, then we proceed at B. What is B? Okay, look at our next process. Okay, now we want to find x1, which is, remember our x0 is minus 1, 0. Now we have our new alpha, which is h, 0.1201 times with d. Okay, will give you minus 0.3995, 0.1201. Okay. Then this is x1. You can have your f h1 Okay, this is the point of x1 where it comes from h1. So f h1 is f as 0.3995, 0.1201. Okay, just substitute the value of x1 here to a function of x1, x2. Okay, then you can have 2.1146. And then GH1 equals to derivative of f by using the same point transpose times with d. Okay, which give you minus 53.4556. Right? Then what? Then again, check whether that GH here is less or greater than 0. This case. Less or greater than 0. If it is less than 0, then again replace alpha with 2 alpha. Same process just like we did previously. Okay. Our new interval is h1 to alpha. Okay. Okay. Then this is your alpha 1. Once you want to calculate ZWH1 here, just use the value of alpha 1 there. Okay. So previously it is 0 to 2 alpha, and then now it is 0.1201 to 0.187. Then the length of interval is the difference between the interval there. So this is your new alpha. Then just find what is your Z1, W1. Now it is H2. Okay, any question? So far, no question. Okay. So what is Z1 here? What is W1 here? What is H2 here? Just substitute to the formula here. Okay. Again, we have 3 FH1 minus F2 alpha over alpha 1 plus GH1 plus G2 alpha. And for W, we have Z1 squared minus GH1 G2 alpha. Then for H2, GH1 plus Z1 plus W1, G2 alpha plus GH1 plus 2Z1 times with alpha 1. Alright, so you need to find what is your G to alpha and F to alpha here. Same process with the previous one. So here we have minus 110 After this, you can try. Okay, so now when can we stop the process? When the magnitude of GHM less than epsilon. And now GH1 is minus 53, okay, which is quite long to reach epsilon 0.001. So again, in our next iteration, we have to proceed with the next point. Okay. So in iteration 2, we need again to find our x2, which is x1 plus h2t. Right? In the previous iteration, x1 equals to x0 plus h1d. So once you have your x2, then you can find your fh1, fh2, gh2, check the condition, is it less or greater than 0, and then identify your new interval and so on. Okay, clear? Anyone has question? Until you reach the magnitude of GH less than epsilon. So for this example, you're going to reach up until iteration number 8. Okay, try. Anyone has question? No? All of you understand this? Understand it's a thing, but know how to do it, you need to try it by your own. You need to practice it by your own. Okay, try it. If you have question, you can ask, refer to the notes. It's quite small, right? Okay, let's take a look at first iteration first, understand. Then you can, if you want me to scroll, just let me know, okay? The final answer in iteration 8, okay, for the interval choice here, okay, this one, You need to check with this. Okay, this one, step number 6. Okay, if GHM greater than 0, the new interval is 0HM. Okay, or if GHM less than 0, this one, your interval is HM alpha. So for this case, you check your GH1, right? GH1 minus 53, which is less than 0. So your new interval is H2 alpha because we choose 2 alpha because this one is less than 0. Okay, then your new interval here is H2 alpha. Then your interval, length of interval is the difference between. All right, but if GHM greater than 0, let's say G here greater than 0, your new interval is 0HM. So the next interval will be alternately changed, depends on the value of GH. Okay, okay or not? That one is iteration 1. Okay. Okay, let me show you. Let me show you in iteration 2. Okay, in iteration 2, this is how you obtain your new point, x2. Just substitute x1. What is your x1 in the previous? Minus 0.3994. H2 is 0.0126. And D is 51. So your x2 is given by minus 0.3365, 0.1327. Okay. Then you can find your FH2, GH2. Alright, just substitute this H2, this X2 to function, then your FH2 is 1.8241 and GH2, substitute this point to your derivative, delta F, okay? Then you have 3.6306. Now, you can see that GH2 now is greater than 0. So when it is greater than 0, this one, then your new interval, since GH2 greater than 0, then new interval is 0 H2, which is 0, H2 is 0.0126. And as you can see, the new interval in iteration 2 is different with new interval in iteration 1, where it is H alpha. But here you use 2 alpha, then H2 alpha. Understand or not? So now, this is your alpha 2. Then proceed to find Z2, W2, H3. Okay? Clear now? So actually, your stopping criteria is referring to this GHM or beta. What is beta? Beta is the length of interval which is obtained from HM. So as you can see, your last H9 here is 0.0005, which is less than epsilon. Then we just can stop. Okay, if you want to proceed, just make sure that GHM, the magnitude of GHM less than epsilon, which is quite long to reach that. Okay, usually we set the stopping criteria for both cases in our programming. Okay, for manual calculation is quite long, but this is how we do it. Okay, is that clear? Anyone has problem All of you understand this? Okay, good. Very good. So this is quite a step, but once you understand, then you can do it. Okay. So going through the example here, you can understand better with the theoretical part. Okay. We find what? This is your minimize function. Okay. Then you find your G naught and G alpha derivative of x. And then you check G naught less than 0. Okay. And then you check the magnitude of h, approximate the minimum. All right. Obtain the lower limit and upper limit of h we have here in the interval there 0 hm or hm alpha. Then the cubic interpolation is applied to obtain a better limit of hm. Right? Then first level we start with alpha, and then the next level you proceed with fx naught plus hmd. Okay, and then eta here can either be 1 or 2, just choose one. Usually we choose one. And then we check, okay, if g naught less than 0, g alpha greater than 0, what happened? Okay, and if these three conditions are not fulfilled, double the value of alpha repeatedly, then hence the double value previously, right? And then for the third level, we want to approximate the function by a cubic function where this is the process to obtain A, B, C, and D. And once you can prove the equation here, it is actually comes from Z. Okay, we want to find Z, W, and so on. Okay, then we can find our HM. Right, better numerical result. No, just omit that. Okay, we want to actually find HM. For minimum, for minimum value will give you HM over alpha equals to this one, where we just put alpha there, right? Okay, and HM here is your beta, and if beta less than epsilon, then just stop the iteration. Complete the process. That is how the theoretical part explain the flow chart, the algorithm here. Okay, clear everyone? From 1 to 10, where are you? All right, good. What about the rest of you? 8.5, 6.5, 7.5. Sama? Bila nak pakai apa tu? 2 alpha or alpha. Bila nak pakai 2 alpha or alpha, you have to check with what? G alpha. Means that G H. Okay? When your GHM less than 0, then you choose 2 alpha. When GHM greater than 0, then you just choose alpha in the algorithm here. When you have G alpha greater than 0, just proceed with alpha. Otherwise, less than 0, it is 2 alpha. Okay? Hmm? Sorry. Okay. Anyone has question? Understand or not? Saidatun. When can we use alpha or 2 alpha? Z1, W1, H2 kena guna alpha 1 or 2 alpha. That one depends on your iteration. Just like this one. Okay. In iteration 1, since GH1 less than 0, we choose 2 alpha here. Actually, it is alpha. But we choose 2 alpha. Okay. 2 alpha, then just multiply with 2. So here, H and 2 alpha here, we only want to identify the length of interval alpha 1. Okay. Then this alpha 1 is here. But for calculation F2 alpha, you still use 2 alpha. Why? Because G less than 0. And then for this case, also 2 alpha. This one greater than 0. Okay, this one is greater than 0. You need to use alpha. Okay. No, usually usually the question will stop you. Just do up to 3 iteration. Just do up to 2 iteration. Okay. No need to reach until the solution point. Otherwise, you won't have enough time. Right? Okay, any more question? Before I'm going to leave you with the rest of the calculation. Okay, until you reach the solution point. Okay, once you can do it by your own, then you can understand. Okay. Okay. All right. Are we good? Okay, so please proceed with the iteration, with the calculation. And if you have problem, you can ask me directly. Okay. So I think that's it for cubic interpolation. Next class, we're going to proceed with hook and jig method. Right. So your test one will cover up until hook and jig method. Okay, now you can try with the tutorial part. Okay, so if you have no more question, I think you can stop the recording here.